Hi folks, Chuck Black here. We're doing 52 weeks of Python. We are in week number 7. Today I'm going to be talking to you about strings. You can see that it's highlighted there. Before I dive into that though, I just wanted to point out a couple of things from Quokka, this thing that I'm working on kind of in parallel that does network monitoring and configuration a little bit. It will eventually anyway. And control. And these are just some things that I happen to notice that are of a little bit of interest to me. Maybe they will be to you as well. So this is my devices table, which kind of the main thing about Quokka is dealing with devices. As you probably know, if you've been watching this before, these first 4 items here are all Cisco Sandbox items that I'm reaching that live up in the cloud somewhere. These always on sandboxes. This is the latest one. This is the CSR just regular one. You can see right here, I also have a netconf one where I'm not using Napalm as I do with the others, but I'm using NC Client to get information directly. And then I have a Nexus device that I'm also using there. Now, if you've looked at these before and you're wondering about them, you may look and see, oh wow, look at this response time, 18 seconds. That is how long it takes me to connect to the device and then to begin to do SSH stuff. Those are all quite big. Look at my netconf one. I don't know why this is so much faster. I need to provide credentials just as I do when I'm doing my CLI type session. Maybe that's what it is, but you can see my response time is way slower. Now, one thing you'll also notice with the netconf one is I don't have any CPU or memory. CPU and memory is given to me quite easily by Napalm for these other devices. But unfortunately, when I want to go via netconf to the CSR device, I'm doing it myself and I need to pull from the XML Yang model stuff, the actual CPU and memory utilization. And I don't know how to get those, at least not right now. So I'm not actually pulling them out. Now, if you were to do Napalm to a Juniper device, then they do netconf naturally, and from there you can probably use Napalm to do netconf and to get CPU utilization and memory if Juniper makes those available. I don't even know if they are. Another thing to point out, these last devices here, these are the ones that I actually have built a simulation of. They're not really, like we talked about before, doing SD-WAN per se, but they are behaving in the manner of some SD-WAN devices, which is they communicate from the device back to the management station. In these situations, we are actually polling the device ourselves and measuring the response time and the availability. In these situations, these devices that live on remote locations are actually communicating back to the management server that lives in the cloud. And the reason that we do that in certain SD-WAN situations is because that's the only way you can do it. In other words, if you're trying to go over the internet, then you need to use HTTP going in the direction of the remote device back to the service, which would be Quokka. And so we're doing it a little bit differently. And you can see I'm measuring the response time. It's obviously a whole lot faster because I'm running my simulated devices on the same actual laptop that I've got dedicated to doing this, an old laptop on which I'm running Quokka. And on that device, I'm measuring myself the CPU and memory utilization. That's just the status of my device at this particular point in time. It used to be a lot worse. Let's see if it actually, you can't really see. The CPU utilization used to be up pretty high because I had a whole bunch of stuff going on that device. But before I did this recording, I turned those off a while ago. The other thing I wanted to point out is this. If you recall, when we went into services, I was quite fond of going at HTTP BBC because that was a website in which I could get response time values that would fail. And so it would show very nicely my service level agreement when it wasn't meeting it. And I had events that were generated that would say something about that. Well, it looks like in the last couple of weeks anyway, BBC News website is way more available. So you can see I'm not having that capability anymore to show that. If I go back, I think the one that I saw had a little blip was Talak, which is ironic since I'm a co-founder of Talak Networks. There's a little bit of a blip around, I don't know if that's maybe midnight or 10 o'clock or something like that. Maybe it went down for a while, came back up. But yeah, anyway, that's just interesting to keep track of this stuff because it's kind of real life data and it's fun to see it in graphs like this. Okay, let's get moving on our string discussion. Let me take a moment and make my screen bigger and easier for you to read, and we'll get started. Okay, so here we are looking at our string code, and what I'm going to do, you can see that we're in lesson number 4 of our basics. I'm going to minimize that, and then I'm going to run this strings code and see what happens. Let me move this over so you can actually read it. Go up to the top. There. Now let me talk a little bit about what it is that we are doing in this code here before we look at the output of that. What we're going to do is I'm going to have this thing called device1_str for string, and it's going to look like this. Now you and I as human beings can look at this and say, I think I can figure that out just by looking at it. It has 4 items. The first item is going to be the actual device name. This is my strange naming convention that I told you about earlier. This is going to be the name of the vendor. This is going to be the actual name of the model name. And this is going to be the name of the operating system. As a human being, I can read that. As a computer, computers have a little bit harder time parsing that. And so sometimes we need to give them a hand. And that is what we're going to be doing here. We want to take this string and put it into easy to handle Python data structure. So what I'm going to do first is I'm going to look at this and say, hey, look at this. There is a comma separating each one of these. That means I can use a function within Python called split. I could do it myself, of course, but like with many, many cases in Python, there's code that's already been written to do things that you will end up doing a lot. And so there's something that will split a string into its constituent parts based on a comma. You can split based on spaces, you can split based on colons, you can split based on whatever you want. In our case, we're going to split it based on commas. So what we're going to do here is we're going to do this because it kind of makes sense, and we're going to look at this. So device 1 using split. Here I'm looking at device 1 using split. Now here I look at this. First thing that I'm going to notice is this little square bracket here and the ending one over there. That tells me that this is what type of data structure? That's correct. It is a list, and the items that make up this data structure are strings. As you can see in the quotes, these are each strings, and you and I look at this and say, great, our work is done. We've done everything that we need to do. But if you look a little bit closer, you'll see, oh, well, gee, I wonder if that's going to cause a problem. There's these extra blanks sitting around. And look at iOS even has a blank at the beginning and a blank at the end. I wonder if there's a way for us to get rid of those blanks at the beginning and the end. And then you look it up on Stack Overflow or wherever you go to find out this stuff. And you find out there's a function in Python called strip, which gets rid of blanks at the beginning and the end. And you look at that and you look at this and you say, that's great. That's exactly what I need. So what I'm going to do here, and this is called function chaining, where I put one function and the output of that function is going to actually be. So what we want to do is we want to get rid of blanks at the beginning and at the end of these things. And so you go to Stack Overflow or wherever you go and you say, look at, there's this function built in called strip, which gets rid of blanks at the beginning and the end. And that's exactly what we want. And so you say, well, let's do that. Let's take device1.string. Let's strip blanks from the beginning and the end. And then let's split this into its constituent parts, into those 4 different pieces. And let's take a look at the result that we get after strip and split. This looks good. This has all of the blanks removed. This one, however, we didn't get the blanks removed at the beginning and the end, nor did we here. And here we got it removed from the end, but not at the beginning. What's going on here? Well, what's going on is the first thing I did went from device1_str is I did a strip. That got rid of these blanks here at the beginning of the string and these blanks here at the end. And then I did the split. And that's why we ended up with this situation. So now you say, well, let me try something different. What if I just say, instead of doing strip, I want to get rid of all the blanks. So I'm going to change all of the blanks into nothing. So I'm going to remove all the blanks. And the way that you do that is you can do a replace function and replace a blank with nothing. And then I'm going to do my split. So when I look at this, replaced blanks using split, this looks good. So I'm really happy. Cisco, that looks good. No missing blanks. Catalyst 2960, that looks good. But wait a minute. Does it really look good? I got rid of blanks that were actually in the middle of this model name. And it may be that it's very important that there be a blank there. You and I can look at that and understand that these two are effectively the same. But a computer, that makes a difference. So maybe we need to do something else. And I'm going to show you how to fix that. But before I do that, I just want to show you one more thing related to what you can do. And in this situation, I'm going to do two replaces. First, I'm going to get rid of the blanks and then get rid of the blanks with nothing. And then I'm going to say, instead of doing a strip, I want you to just replace the comma with a colon. Now, I want you to look closely at this. What is the difference? Well, yeah, the difference is we got rid of the comma and replaced it with a colon. But look closer. What is this thing right here? It is a list of strings. What is this thing right here? It's just a string, okay? We printed this thing out and it printed out just a string. So I don't have it separated into its constituent parts. Now I could separate it and then I'd end up with something like we have up there. But I just pointed that out just so that you're aware. Be sure you're cognizant or aware of the difference between these functions. In certain situations with split, we changed it from a string into a list of smaller strings. And in the other situation where we just did replace, all it did was replace and it left the string intact. So let's see what happens if we want to do this and get it the way that we want it, which is going to be just like this one right here, but we don't want to touch the in-between blanks. We want to leave that and however many of them intact. How can we do that? Well, here's one way to do it. What I'm going to do is use a loop, and I'm going to create device one, which is going to be a list of these different portions of the device. And now I'm going to use the for loop that we've seen before. Remember, with a for loop, then we can go through, if as long as something is iterable, then we can do a for loop just like this, and it makes it very easy. We don't have to use indices or anything like that. Now, device one string may be iterable, but as a string, that would give you one character at a time. That's not what we want. But device string dot split, that gives us basically this right here, which is what? It is a list of strings. So it is a list. That's what we want. We can go through here and it will take items one at a time. The first time through this loop, it will give us that item. The second time through will be that item, and so on until we get to the end. So we're going to go through this list one item at a time. I'm calling it item. And what am I going to do? I'm going to append that item to device one. That's our list. But before we append it, I'm going to take item and do a strip. What does strip do? Remember, it removes spaces from where? From the beginning and the end. So that's going to work there. It's going to work for the second one. For the third one, it's going to get rid of them at the beginning. It won't do the ones in the middle. It's only the beginning and the end. And for iOS, it's going to do it at the beginning, at the end. And so here's device one using loop and strip for each item. And when I look at this, guess what? This is exactly what we are looking for. Here's my device name. Here's my device vendor. Here's my device model. And there's my device operating system. So we've done this correctly, and that's great. Now, the next thing that I want to show you is a different way to do this. Some would say that it's better. It will certainly be more confusing, and I don't believe we've talked about this before, so you need to listen up closely. What's going on here? I want to do exactly the same thing with device 1 string, but let's look at what's on the right-hand side of this equal sign. I'm going to assign to device 1 something in brackets. If you're a guessing person, what would you say that this is? You would say that it is going to be a list. That's correct. If you see something like this, then it's going to be a list. And if you look inside of it and you see a for loop, then you know that it is going to be this thing that we call a list comprehension. So a list comprehension. And what is going to happen? Look at this for statement. The first statement in my for loop, this is what we're going to do. For item in device 1 string dot split based on a comma. Does that sound familiar? It should. That is exactly what we have right here. Okay? So this is a for loop inside these square brackets. Now the result of every iteration is going to be something that we call item. And now in this list iteration, I could just say item right here. And what we would end up with in this situation, in fact, just for kicks, I'm going to run it. And let's look at our list comprehension. Look at our list comprehension. It still has the blanks in it. For every one of these, it has the blanks. But I'm going to come back and do what I did before. And I'm going to say item.strip. And so I'm going to apply .strip to this item, and then it's going to get put into this list. And let me run this, and then we'll come back up and we'll look at the output. Sure enough, it's done a strip on every one of these. Notice in the Catalyst 2960, it has left intact the interior spaces. It only removes spaces from the beginning and the end. And with iOS, remember there were spaces actually at the beginning and at the end, and it's gotten rid of them. So in one line, I have transformed this string, which is kind of complicated to parse and get all the individual parts out of it. With one line in this list comprehension, I have come through and created a list, and I know that item 0 is going to be the device name. Item number 1 within it is going to be the vendor name. Item number 2 is going to be the actual model, and then number 3 is going to be the operating system. Okay, so let's look at a few more things that you might want to do. Now, if you're in a situation where you want to look at the model of a particular device, here's an example of a model of the device, and if we wanted to compare it to this, you and I could look at that and we would say, oh yeah, that's okay, that's not a problem. Those two are the same. Unfortunately, it doesn't work that way for computers because they're going to want it to be exactly the same. And in this situation here, I'm printing out whether it matched or not. And in this situation, we're going to find that it did not match. So what do you do in situations like that? Well, one of the ways to do it would be to just, if you know that you're dealing with something in lowercase, you can just do lowercase on one side. If you're not sure, you could do lowercase on both sides. But this will say if model.lower, it will lowercase this and compare it. And in this situation, we can say, okay, well, it did match correctly. If I were to do something silly here, like an R, and we were to run this again, then what you would see in this situation, which is the second situation where it's supposed to work, you can see that it actually didn't work. And so in those situations where you don't know what you're going to be dealing with, then you can just apply .lower to both sides. So if you've got two sides, this side here and this side here, and you don't know if there's going to be capitalization or not on either side, then you can do a .lower, and we can see that this will actually succeed and it will be a match. So you can see that it did match successfully in that situation. You can, of course, do upper if you want. Other languages allow you to do an ignore case when you compare strings. Python, because of the simplicity and the way it is to compare strings, just like you can compare actual numerical values, then what you need to do is you need to apply lower to both sides or whatever type of normalization that you do. Now the next thing we're going to do is we're going to look at how do you find if there's a particular string in a substring within a string. So in this situation, I've just chosen we want to look for a particular value. This is not necessarily meaningful, but what we're going to end up doing is we can see that that value is actually within this version that we've gotten from a device. So we're going to do a .find. Find is going to find it, and it's going to tell us actually where it found it. I'm going to print out the index because it returns an index of where it found it. And if we look over here at where it found it, it says it found version yada yada at location 55. Now, what about taking that version string? Can we do something more interesting with it? Because it's very bulky and cumbersome to deal with. So what we're going to do here is we are going to say we're separating the version string components. Remember our version string? Let me make this a little bit bigger. Here you can see, well, let me show you the code first. I guess that would make sense. Here's version info. Remember, what is version info? It is actually, when we start here, this is version. So version, what is version? It's the string, right? I could have said version underscore str to make it a little bit clearer. But version is a string. I'm doing a split based on a comma, and I'm going to say version info is now a list of the different items, and I'm going to go through them, version info part in version info, and I'm going to print them out. And if we look at what it actually prints out, here we say separating version string components. That's what this is saying right here. And here it prints out the first part. Let me make this bigger. Here's the first part, here's the second part, and here's the third part, sure enough. Now, you may be saying, okay, well, I want to know which part that is instead of just saying part whatever. Let me show you something that you can do in Python that allows you not to have to worry about counting up the index. If you wanted to say part 1, part 2, and part 3, you could create a variable called I and start it at 0 and increment it. But there's a really handy function in Python called enumerate, and that provides you both the index as well as the item that you're interested in. So let me change this code and then explain it to you. Okay, so I've actually coded it correctly, and we can see what we've done. The first thing that I did was I said, okay, I want to do this enumerate thing. Enumerate is a built-in Python function, and when you enumerate over an iterable, you end up with two parts for you to iterate from the iteration. One is going to be the actual item itself, and then the first item that you get back is actually the index. And so all I changed was I added a space and then print out part number. And so when we look over here, the only difference in the output is we can see part 0, part 1, and part 2 that corresponds with the actual string that we were looking at. Remember, this right here is going to be part 1, this right here is going to be part 2, and this right here is going to be part 3. So there we've not only separated it, but we've also learned about this thing called enumerate. A lot of people will say come in here and say I equals 0, and then they'll have to print out I here, and then they'll have to say I equals I plus 1 or something like that. Actually, you can abbreviate that to I plus equals 1, which will increment it. You no longer have to do that. You can just use this enumerate functionality, and it does it all the way for you. That's a very handy thing in Python. Okay, so this next part, what we're going to be doing is we are going to attempt to take output from a device, like I've put right here, and parse this big long string into something that can be usable in a Python type of data structure. And if you look over here at the output, this is my interface counter output. I've got this thing right here. You can see this is what curly braces with a key on one side and a value on the other means it's a dictionary. So I've got a dictionary with 2 items in it, gigabit Ethernet 1, gigabit Ethernet 2. Those, as you can surmise, are going to be the interfaces. And then these are actually the values, the counter values that we're getting back because we're looking at interface stats command output. And then the next thing that we're going to do is we're going to look at an ARP table and take the actual textual output and change that into a dictionary with, what's this, an IP address on one side and a MAC address on the other. And I'll show you how to do that. Now this may be a little bit more complex. Some may say a little bit convoluted. Quite often that's what you end up dealing with when you deal with output from a CLI. It's easy for the human to read, hard for a computer to read. So I'm going to show you ways to do that. These are not necessarily the best ways. Those may involve more complexity, but I do want to point out some different aspects of dealing with strings as we go through it. So here's my show interface stats. I'm going to come down here to the code that actually does it. This is my interface counters. This is where I print it out. So what I'm going to do is I'm going to create this thing called interface counters, and that's a dictionary. And the first thing I'm going to do, show interface stats, remember, is this big string. Strings that have 3 quotation marks are multi-line strings, so that helps you to understand that a little bit. It's in green, so you know it's a string as well in this IDE. It makes it a little bit easier. So we're going to take show interface stats and do something. Oh, here's a new thing, split lines. What do you suppose that does? Well, when you have multi-line output, say from a CLI, then what it's going to do is it's going to change that one big string into multiple strings. And you're right, as you guessed it, every string is going to be a separate line. So you're going to have a list of strings, and those strings are going to represent lines from the output. So once I have executed this command, split lines, I'm going to have show interface stats lines. It's going to be a list of strings, and every one of the strings is going to be an individual line in this output. Okay? So now we've got the lines. Since it is a list, what does that mean? That means that we should be able to iterate over it. And so we're going to do that. We're going to iterate over each one of these lines. And so my for loop here is actually going to use the functionality I just talked about, this enumerate functionality. All that does is it does a normal iteration, so you have a one line at a time, but it also gives you the index of that list. You could call that line number if you wanted to. So what we're going to do is we're going to say, go through this particular line that we're looking at, and you're going to say, for this stats line, if I can find the word gigabit Ethernet in it at location 0, then I'm interested and I'm going to do something. And here's what I'm going to do. This is not necessarily the best way to do it, but this is a way to describe for you these different string functionality. I'm going to use find to find this at location 0. So anytime I see gigabit Ethernet somewhere else, if it happened to be out here, I wouldn't match it, but if I match it at location 0 right here, so I'm matching gigabit Ethernet. If my line has this exact string, gigabit Ethernet, in it, then I want to do something. And what I'm going to do first is I'm going to take and look at, here's my show interface stats lines. That's all of the lines here. I'm going to look at the index that I'm at plus 5. So this is kind of a cheater way to do it, and I even shudder when I think about it, but I'm actually pointing right here at this line. But what I'm going to say is I want you to go down 1, 2, 3, 4, 5 lines from here, and I'm going to deal with the string here. Now there's a number of reasons that this may not be the best idea. If I don't have lines plus 5 in here in the actual output of these show interface stats lines, then I'm going to end up with a problem. But just for the sake of showing you, I'm going to go to line where I was, Gigabit Ethernet, plus 5, which is going to be this line. So now I'm saying, give me this particular line. That's the line that I'm interested in. And what am I going to do? I'm going to call that the totals line. So when I go through this, every time I see Gigabit Ethernet, I'm going to go down to the totals line associated with it and do something with the totals line. So etch that totals line in your mind, or we can cheat and look at these from loopback. It's the same type thing. Now when I get to when I have the totals line, it's this string right here. What I'm going to do is I'm going to say, okay, my interface counters, remember that's a dictionary, my interface counters substats line, that is the actual Gigabit Ethernet word. So this word right here is going to be the key to my dictionary. And if you look over here, you can see sure enough, Gigabit Ethernet 1 is one of my keys. I'm going to say interface counters sub, my key is stats line, that's the thing that says Gigabit Ethernet. I'm going to set it equal to my totals line that I just calculated here, and I want to take that totals line, which is just a string, I'll use this one as an example, and what I want to do is I want to split it, but look, I'm doing a split based on what? Based on nothing. So what is the default thing that it's going to split on? It's going to split on blanks. So if you split it based on blanks, then it's going to basically take, this is the first item, item 0, this is the second item, this is the third item, this as the fourth item, and this as the fifth item. Okay, so it strips away. It's another way to look at things. If there's just blanks, then it's a good way to go from a string with columns with blanks in between into a list. So I'm going to say totals line dot split, and now I'm doing something somewhat interesting, and I'm going to explain it a little bit more in the next example. I'm going to take a slice of that and what of that list, and what is going to really happen in this situation. This is the syntax for taking a portion of it. You can do this to strings, and which we'll see in the next example, or you can do it to lists. This one says, I want you to start at item 1 and go, if you don't have anything here, then you say go all the way to the end. So nothing is specified there. What is item 1? Well, remember, with lists, what is the first item number? The first item number in a list is always item number 0. So basically, this is going to take all of the items from the result of this split, except the first one. It's going to ignore the first one. Let's look up at this line, since we're using this just as an example. What's item 0? Item 0 is this thing right there, is that string. Item 1 is that one, item 2 is that one, item 3 is that one, item 4 is that one. So we're saying we're going to take totals line after we've done the split, and we want to start at item 1, which is item 1, this one right here, and go all the way to the end. Now the values in these for Gigabit Ethernet 1, the first item 521674, guess what? It matches this one here. 621.77492 matches that one there. And when we go down to Gigabit Ethernet 2, then you can see this 6096 matches here. So what did we learn here? We learned that we can do split lines. That was a new thing. So we took this output from a CLI and we applied split lines to it. So we have the individual lines. We use enumerate again, so we know what line we're in. So we have this index that we can deal with it. We did something kludgy, which I probably in normal situations might not recommend. There's other ways to do this, but just to demonstrate this functionality, we said, okay, we're at this line right now. I want you to go down 5 lines from here and take this data. And that's what we did here. We said index plus 5, that's the totals line. This is where in the index was in that situation. If that was gigabit Ethernet, this is that particular line right here, this one, except up here with the gigabit Ethernet stuff. And then we said for that particular totals line, I want you to do a split based on space. And then I don't care about the word total. I only care about the actual numbers. The packets in, packets out, characters out. And so we have extracted all of this interesting data. So hopefully that makes a little bit of sense. When it comes through here and it sees a line that does not say gigabit Ethernet, what does it do? It does nothing. It just goes to the next item. All right, let's look at taking this ARP output and doing something with it. What we'd really like, this is nice of Cisco to print out all of this interesting stuff, but really I just want to build a basic ARP table that has the IP address and then the associated MAC address that goes with it. So how can we do that? Well, this is how we can do it. We're going to take this thing called showARP, that's the showARP output, and we're going to do our friend split lines. So we're going to go through here, and each one of these lines is going to be an item that we iterate through. We're going to say if arpline.lower find internet at location 0. So if it finds the word internet at location 0, if there's a word internet anywhere else in here, it's going to ignore it. It has to be at location 0. If that index is equal to 0, this is a little bit redundant, but it just reinforces that the index is 0. Then what I want you to do is I want you to create my ARP table entry. And what are we going to do? Remember, the ARP table entry is going to have the key right here. Don't look at the details of that just yet. And then this is going to be the value, right? It's a dictionary. Here's the key, and here's the value. So what is the key going to be? Well, when we look over here at the output, we want the key to be the IP address, and we want the value to be the MAC address. How are we going to do that? Well, this situation, once again, is dependent on where these items are located. If somebody was to change the CLI, which can happen, then we would be at the mercy of that change, and we would have to change our code or do something different. But I'm using this example to help you to understand how you can slice a string. So we're looking at the key. What we want is the IP address. The IP address we can see is right here. How can I get that value out of the string that is this string right here? Well, the string is called the ARP line, right? We're going through this one line at a time. It's the ARP line. And we're on the line that says internet. So I'm going to say, I want you to take the value of ARP line, but only from location 10 to location 25. All right? And remember two things. Number one, it starts at 0. And number 2, it ends at the spot before this. So it's actually the last one that you get is the 24th item. So it's going to take this particular string, which is going to be like this. See how I've highlighted that? It has spaces at the end. What am I going to need to do to it? I'm going to need to strip off that excess white space because we want it to look like what it looks like over here without any extra white space. Hey folks, I just wanted to jump in and say that yes, you could use split as we've done previously, and that would work. It might even work better, But the purpose of this little exercise that I'm showing you is so that you can learn a little bit about this slice functionality for strings, which can come in handy in certain situations. So we now return you to your description of how this works. And that string, which is basically going to be this for the first one, this for the second one, this for the third one, is going to be what we have as the key in our dictionary. Now let me pause for just a second. Remember, we mentioned square brackets on the right-hand side over here, or when you're printing out data. If I go back to my list comprehension, if I can find it, on the right-hand side of the equal sign, see my equal sign? On the right-hand side, that means that's data, and in that situation, it means that it's a list. But like right here, or down here, it means it's basically a subscript. Or in this situation, it's going to refer to a range of items within that string. So this is just going to be taking items 10 from location 10 to location 24. And then it's going to strip the excess stuff off. So ARP line, which is a string, it's going to start at the string at location 10 and go to 25. Then it's going to strip it. That is our key. So ARP table, the key is this thing right here, over here on the right. Now let's look over here. What is the actual value that we're going to assign to it? Well, again, we have our ARP line. This is this entire line. What if I want to get, how do I get the MAC address? Well, I just have to count from the beginning, 1, 2, 3, 4, blah, 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 blah. 38, this is where that begins, 38 to 52. And that is going to be my MAC address. Now, why do I not do a strip on the MAC address? Because as you networking guys know, the MAC address doesn't have any blanks in it. It always has these hex characters, and it is always going to be, depends on the format. In this format, it's going to be 4 times 3 plus 2 characters. In other formats where there are dashes in between, it will be somewhat different. So you just need to be aware of that. Dealing with a Cisco device, this is the way that Cisco likes to print things out. So we've seen a lot of things in this. We've seen different ways to parse a string, to use split, to use strip. We've looked at what replace does. We've done a for loop that actually went through and did a strip for each item. We used a list comprehension. That was the new thing. We went through and we did lower in order to do our matching of things, and that worked. We found out how we can find substrings by doing that from a version string. We've separated the version string again using split in order to get it into its constituent parts. We learned that you can use enumerate to get the actual index of our iteration. So when we iterate through things, we actually can get the index as well. And we took output from show commands. This was show, what was it called? Show interface stats. So we looked at interface stats and we changed this bulky human readable but not computer readable output into something that is computer readable. It's a dictionary with the key being the interface name and then the values being a list of packets in, packets out, etc., bytes in, bytes out. And then we did the similar thing with an ARP table, except with the ARP table, we had to do some slicing of the strings in order to give me different components from that output. And that gave us the IP address and the MAC address. And remember, we had to do a strip to get rid of the excess blanks. Hopefully that makes sense. If you've never done this before, some of it may make sense. Some of it may make sense later. Hopefully this will be useful to you in your endeavors as you learn Python and you have to deal with some of this ugly CLI type output from devices or any other things that you might be doing with strings in Python. And believe me, you'll be doing it a lot. Okay, so let's talk a little bit about Quokka here. This is the picture that I originally showed you. I think that that's busier and it might have too much information. This is the general simplified view of everything that's going on. you can understand there's a bunch of open source stuff that is kind of surrounding the code that I've written, but you can think of it like this in a general sense. So let's look a little bit at how to run it. And when we look at the data to find out where that data is actually coming from. So here is an example of Quokka that is actually running on a different device. I've got my old laptop running Quokka. We can drill down for actually looking at devices. We're showing CPU utilization, memory utilization, availability, and response time. When we look at something like services, if I was to go to my favorite, the BBC, then I can see there's response time and availability, but I'm also keeping data over time so that this is the last, I think, 24 hours or so, maybe 30 hours of data, and the same thing is true here. So how do we actually run this and get everything started such that everything is going to be running? So what I'm going to do is I'm going to start the 3 different components manually here so you get a general idea. I'm going into the Quokka directory and I created something called run Quokka, and I can do that. It's going to go out and begin to run. You'll be able to see things like it's monitoring hosts, it's monitoring services, it's also discovering devices. So it's going through and trying to find out what devices are actually on the network. I actually delete the database of hosts before I start just because those can change. I'm going and getting stuff from devices. So you can see I'm getting environment information from CSR Sandbox in that situation. So now I've got that part of the product up and running. I'm going to start a new terminal. And this terminal, actually, I'm going to start the GUI. So I'm going to change directory to Quokka and then to Quokka UI. And from here, again, I have something that, oh, wait a minute. I just realized I put my script to start the Quokka UI in the Quokka directory. So I can just say run UI. And it will actually go down into that directory and it will begin to start stuff. Now I have, at the request of David, I have created a single script that does all of this stuff to make it simpler, but it kind of confuses things. So I'm showing this to you in their independent entities all by themselves so you can see what's going on. This is the Quokka code that's actually doing the monitoring of services, hosts, and devices. This is the user interface. You saw that it tried to start stuff up. Sure enough, this is Quokka that's running on my local host. You can see that I have actually, at this point in time, I've talked to my Sandbox devices. I don't have any communication yet with these simulated SD-WAN devices. That's because I haven't started the simulator stuff. So why don't I go ahead and get that started? So I'm going to get another window out, and this one I'm going to put down here, and I'm going to go into Quokka, and now I'm going to say run SD-WAN sim.sh, and you'll see I'll make this a little bit wider because it's a little bit easier to read. Every second it's gone through, it's waited a second between doing each one of these and sent heartbeat. You'll see periodically it will skip sending a heartbeat for a few times. That's just so that the data gets to be a little bit more interesting. If we go up here to the GUI, then you can see that we've refreshed it and I've got these 3 have been heard from. If I just refresh it right now, you'll see that they're all up and running. If I go back to that particular terminal in a minute, then depending on the randomness, it will probably skip sending heartbeat for one of these devices, and after like a heartbeat and a half interval, then the Quokka code will be able to recognize that, hey, there's something wrong here. Let's go over to hosts and look at what's going on here. So here you see that we've only discovered 10 devices. So we're going out and trying to discover them. You can see the IP address. I've gotten up to 47. I know I have some in the 80, 90, etc. And I think I have some in the 100 as well as I add new devices to the network or retire old ones and I get a new IP address. So let's see if I refresh it, I still only, oh no, I have 14 of these. I can actually make this bigger, and you can see there sure enough, 78, 79, 80, and 81. These are my smart outlets that govern plugs in my home. David had mentioned that it might be a good idea to try to hack into one of those at some point in this course. So I've been playing around with some of the tools for sniffing things in the network and injecting packets into the network, and I might be doing that. Oh, and by the way, just if we go to services here and we look at a service, you can see I've started to get some data points, but I don't have this summary. That's because it hasn't been running for hours. It would have to be running for at least 1 hour. Well, not at least an hour, but every hour at the top of the hour, and we're only at 20 minutes after right now, it will summarize the previous hour. So when it gets around to the top of the hour, it'll summarize what has just been done, and then there will be one data point. And if I were to let this run for a long time, then we would end up with a lot of data here. So you're probably a little bit interested in how does this actually work, and I want to walk you through it a little bit. And if you are a new person to all of this, this is going to be something that you probably won't understand much of it. If you're a little bit intermediate, then you'll probably understand in general what's going on. In either case, I think it might be beneficial for you to pay attention and just to see, okay, what is this guy doing in order to make this happen? So this is my init module. That's, remember, what Flask calls. Actually, I don't know if you remember it. I've created some code that talks about this at the beginning, and I will be going through that later on in these 52 weeks, taking you through things from scratch. But this init is what gets called initially for our Flask application. One of the first things that it does is it's going to read in all of these intervals. It seemed like a good idea to have this configurable, so we're reading from the command line what these different intervals are. Now the next thing that we do is we're going to do our database stuff, and this is where we are actually doing SQL alchemy and associating our application with the database. You can see I have commented out our connection to SQLite. That's because I'm using a real live database. That would be Postgres. And this is all I need to do in order to associate myself with it. And then we can use some of that database stuff that we've talked a little bit about. The next thing that I'm doing is, creating everything, and then I'm importing devices, and I'm cleaning up my host table because hosts, as I said, I delete them and then start over. These things, import devices, import compliance, and import services, those two will erase what was there before and start anew. This is a training program in a real world situation. You would not want to get rid of your database. You would want to preserve it. However, when you change things in the database, like I've been doing, migration becomes a difficult task. We're not going to go into that here, certainly not at this point in time. Now, the next thing we do is we get rid of all of these time series data and the events. And now the next thing that we do, and this is it, because this is all that happens at the beginning, is we call into this thing that I've created called the thread manager. You can see it over here in the list of code, and I'm going to be starting stuff. By the way, I just realized I should make this big for you. So let me make this bigger now that we've looked at the stuff that we need to look at. All right. Yeah, so we went through this. We read all of the intervals from the command line. We created our database connection. We deleted all the old data. And now we are calling this thing, this class that I created called Thread Manager. And that I created that because the starting and stopping of threads, while in and of itself is not a difficult thing, I found that when I was trying to shut things down in a graceful manner, it was actually causing me problems. So for our purposes, we're going to look at starting service threads. And if I go down here, I'm going to do Control B because my IDE in a friendly manner takes me directly to that thing. Here's my code where I say start service thread. And what I'm doing is I'm creating this thing called service monitor task. If you look over here, you can see I have created a class called service monitor task. then all I'm going to do, and this is the way that threading works in Python, is I'm going to start my thread and I'm going to give it the name of the actual function that I want it to call, and I'm going to pass in the arguments, which are going to be the interval that we saw earlier, and then I'm just going to start that thread and it will get to be running. So I know we haven't gone through this. Let me take a brief moment and explain to you what a thread is. If you're new, we have looked at stuff along the lines of a simple file, which is called a module, that does something very simple. And the way that Python and every programming language works, for the most part, is you start at the top and it executes these things one line at a time. Boom, 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 until it gets to the end. And the only difference is when you have something like a loop. And in that situation, it goes and it executes this loop some number of times, however many times, and then it's done. The idea of a thread is this. You can launch a thread, and your thread will go out and it will begin to execute independently all on its own, as if it was its own separate program that was running. And so I am going to be creating separate threads for service monitoring, host monitoring, discovery of devices, monitoring of devices, compliance monitoring of devices, and just to go down here, the one that I missed, doing the summaries. This is going to wake up every hour and it's going to do my summaries. So basically these things are going to come to life and they're going to run. Now, before you get overwhelmed with exactly what that means, let me remove these and let's go look at what actually happens. So we are going to go to this monitor process, this monitor function, and notice this is within service monitor task. So remember, I created it, I passed in the interval, and then I said that I want you to monitor this, and here's my interval. And what is this code going to do? Well, let's look at this line right here. This is fairly self-explanatory. While true, what does that mean? That means this is going to execute forever. So it's just going to loop over and over and over again. And when you think about what you want a monitoring task to do, you do want it to continue to run over and over and over. So it is in charge of its own destiny, this service monitor task. The only exception is if I come in and I've set the terminate flag, which I will do when somebody asks me to shut this down. And that will allow me to shut down gracefully. So let's look at what this does really quick because it's pretty simple. First, I go to my database and I get all the services out of my database. I'm going to do this every time through. The reason is if some other entity has added services or deleted them, I want to make sure I get the most recent copy. Since I'm running this monitor every minute or so, it's just a fraction of seconds to go get the services, so it's not like it's costing me a lot of overhead. Once I do that, I'm going to have a for loop. So even if you've only seen the beginnings, you have a general idea. I got my services as a result of calling get all services. Now I'm going to iterate through every one of these services. So for every service, I'm going to come through here and do this. And this is all I'm going to do. For that service, I'm going to call get availability and response time. So where is this defined? It's actually defined inside this class module. And it's actually defined outside of the class, so it's on its own, but it is a function that I can call. And it's passing in the service. And you can probably understand what this is doing. Obviously, I want to get the start time for the beginning of my monitoring. If the service is HTTP, what do? I use this Python library called requests. I'm not creating all this stuff on my own. I'm just doing a HTTP GET request and passing in the service target, which may be Google or Wikipedia or any of the other ones that we have listed in there. That's it. Once we're done, if we got a response, then we're going to say the availability is bad. And if we don't get a response, we'll say the availability is unavailable. And if we did, then we're just going to calculate the time, the response time. What if the type of service is DNS? Because remember, when I go to my service screen, which I'm going to do here, these are different types of services. I have a couple of DNS services. Those are doing NS lookup type stuff. These are just doing web requests. And then I have one NTP request. So let's go back and look at what I'm doing. If the service is DNS, what am I going to do? Well, you may ask, what is this resolver thing? I did not write the resolver. It is another library that I have imported, DNS resolver, and basically all I need to do in order to resolve my DNS requests is to come in here and do a query. And so I'm doing my resolver.query. This is all defined as part of this resolver. It's not special Python stuff that you need to know. It's just part of the way that they defined their library. And I'm calling query. And what am I passing in? I'm passing in the DNS name to look up. So in our situation with these DNS, what is the data that we're looking up is what we're actually going to be trying to resolve. And I have different ones that are doing different types of going to different name servers. All right, so let's go back to our DNS. So we've created this target resolver that is specifying what is the DNS server, that 8.8.8.8, which is Google, or the other one, which I think is OpenDNS. And then here, the data is actually the host name that is getting resolved. I have a generic name for that called data because we might have different types of services. And then all I do once again is if it's available, I set it to true and calculate the response time. If not, then all of these bad things could have happened. The last one is right here. If the service is NTP, then what I'm going to do is I'm going to get the server for NTP. What is NTP client? Once again, you won't be surprised. I did not write this. It's part of this library called NTPlib that I imported. And I come down here and do my NTP. It's pretty straightforward. I make an NTP request and I get a response or I don't get a response. So all of these are pretty straightforward. What I do, and then I return from my function. Remember, I'm in this function. Sorry for scrolling so much. I'm in this function called get availability and response time. And at the very end of it, I'm going to return whatever I've calculated, availability and response time. And so when we come down here, and here's my request to that function, and I'm retrieving availability and response time. And so I print out some errors if they weren't available. I update my service with response time, last heard, etc. And then I go and I do two things. I record my service status. So this is putting it into the time series database. And then I also update the actual service itself because within the service object, I'm keeping this last heard and the response time. That's so that when you look at a service, you can see response time and last heard. And that's it, really. This is all that the function does. There's not a whole lot of code here. It's a lot of value for a small amount of work. If I wanted to add new services, what I would probably end up doing is creating something a little bit more elaborate from a Python perspective. Do each one of these different services, HTTP or DNS, maybe in their own class. But for right now, just trying to keep it as simple and small amount of code as possible. This is how I've implemented it for now. Hopefully that makes some sense. That gives us this nice information. Oh, look, BBC went down. Cool. Unfortunately, I don't have I don't have any hourly data to see if it's meeting SLA, but you can see that it's kind of going up and down. So maybe it will continue to have that, variable type of response that gives a more interesting looking graph. Anyway, there you go. That's Quokka. That's the service monitoring. Hopefully that made a little bit of sense and you understand a little bit how easy it is to build something like this from Python, mainly using a little bit of Python knowledge and a lot of help from our friends. Those friends would be the people who have written the DNS and HTTP and NTP libraries to help us to actually query those services.